going to start and welcome our first speaker. We have Dan Chase from Res, who's going to give a talk. And since I'm up here at the mic, I will just go ahead. Transition. Yeah. And this. All right, it should come up here in a second. Just go ahead and use the arrow to advance slides.
Excellent.
We'll listen for your audio. Make sure.
So just a quick note, Randy, the PowerPoint's in presentation mode. So we see the sort of note slides rather than the presentation slides.
Thank you for saying that. I'm going to make a quick change here and hope. Let's see. Got it. Always a slight delay here.
That looks good.
Great. Okay. Thanks, Dan.
Hey, good morning, everyone. Thank you so much to Randy and KBMP for having me here to speak today. And thank you so much to the KRRP for hosting us here on their lands and at their facility. My name is Dan Chase. I'm a fisheries biologist with Resource Environmental Solutions, and I'm here to talk to you about the Lower Klamath Project restoration monitoring that's going to be done. This is going to be a high-level talk, just given the amount of time we have, but the intention is to kind of frame out the monitoring that's going to be done for performance measures. So for this talk, I'll be talking, provide an introduction to who our company is and what our role is on the Lower Klamath Project. I'll speak just briefly about some of the restoration activities to help frame up the monitoring work that's going to be done. We'll be talking about monitoring performance and then some of the fisheries and aquatics related activities that are going to be a unique source of data generation we anticipate. So Resource Environmental Solutions, or RES, is the nation's largest provider of ecological restoration and mitigation. We have over 1,000 employees nationally operating out of 40 operation hubs. We are considered an operating company. We are involved with land management, acquisition through fee title, and we will do full restoration. That's all our company does, is restoration through the course of permitting, design, construction, and implementation. And then we take a long-term stewardship view of our work. And so we manage lands for extended periods of time and for perpetuity for some of our ecological banks. See, advance the slides here. There we go. Nationally, we've planted tens of millions of trees. We have restored and preserved tens of thousands of acres and have restored and protected hundreds of miles of streams and tributaries nationally. Our role on the Lower Klamath Project, which many of you know as the Klamath River Renewal Project or the Dam Removal Project, is that we serve as the restoration contractors for the Klamath River Renewal Corporation. We are responsible for restoration design and implementation. We're supporting the regulatory process, the approvals process, which has been underway for the last several years. We're implementing the biological conservation measures. We're responsible for the long-term monitoring and maintenance to meet performance criteria for ecological restoration. And then we have a performance guarantee. And this is a really critical part of this project. It was required for both FERC, the Federal Energy Regulatory Commission, and the Klamath Hydro Settlement Agreement that the ecological restoration have performance guarantees that are owned by a company. So for this work, what we are doing is a progressive design build, which means that we are involved with designing the restoration. We support the permitting so that we understand the terms and conditions that the work needs to be constructed within. We developed success criteria with our state, federal, and tribal stakeholders. We have a number of partners that are involved with this project that are informing the performance criteria that the project is being held to. The construction will either be self-performed or in a combination with experienced local subcontractors, but it will be done under the guidance of RES. And then we monitor and maintain, we do the monitoring and maintenance work associated with the monitoring period to meet performance. Importantly, RES is responsible until success criteria is achieved and approved by regulatory agencies. We recognize that this has been multiple decades in the work by a number of project contributors. On the screen is just a small set of the people who have been involved to get us to where we are today. We do recognize that this work is being done underneath the Klamath River Renewal Corporation under their guidance and leadership as well. And let me switch slides. And for the tribal nations within the basin, specifically the Yurok, the Karuk, Hoopa Valley, Klamath, and Shasta tribes, have put in countless hours to progress dam removal to the point that it's at today, and that the dams continue to impact cultural ceremonies, practices, and culturally significant resources in the basin. Now, the project purpose of the Lower Klamath project is to achieve dam removal, a free-flowing condition on the Klamath River, and volitional fish passage. This is done through the deconstruction of 4 hydroelectric dam facilities on the Klamath. And it's important to note that these dams are not operated for flood control and do not provide water for agriculture or drinking. The project area is shown here in the middle of the screen in purple. It's the hydroelectric reach is another name for it. It has Copco #1, which was the first dam that was constructed and completed in 1918. That was followed shortly thereafter by Copco 2. And then in Oregon, it's the J.C. Boyle Dam, which construction was completed in 1958. And then the most downstream dam, which marks the upper extent of anadromity in the Klamath Basin, is Iron Gate Dam, which was constructed and completed in 1962. These are the 4 hydroelectric facilities that are going to be removed as part of this project. Talking about schedule, Randy brought this up a little bit earlier, but through this presentation, you will see different periods of time referenced here. We think about them kind of in 3 groups. There's the pre-drawdown period, which is the period we are essentially in right now. That is work that is done prior to the drawdown of the reservoirs. Restoration construction, we're showing this as a 2-year period. That includes the drawdown of the reservoirs and the deconstruction of the dams. And for restoration, it includes the initial restoration work and then our year 2 of restoration. So we have a 2-year period, and then we have a monitoring and maintenance period, which extends past that. We anticipate that to be a 5-year period. However, it's going to be contingent upon performance criteria being met. And once that occurs, and if that's not met within that 5 years, we will continue to do the monitoring and maintenance. It's important to note here also that maintenance is included with the work. It's not just monitoring to identify issues, it's actually to correct them as well. For schedule, we anticipate, based on the FERC process that is underway and the government approvals that are remaining, that we are on track to begin pre-construction work in 2023. So the pre-construction year shown on these slides will be 2023. That will be the start of the dam removal activities as well, with dam removal completed in 2024. So our restoration construction period will be 2024 and 2025. And then after 2025 begins our monitoring and maintenance period. Just touch briefly on some of the restoration elements just to really frame it for the monitoring work that's going to be done. We have 3 primary goals for restoration. The first is to achieve, and this is also in order as well, is to achieve a free-flowing river condition that supports volitional fish passage. The second priority is to stabilize remaining reservoir sediments. This will be done through supplemental sediment evacuation and removal activities, and principally through stabilization through revegetation efforts. And then the third priority is habitat enhancement, principally looking at the former reservoir footprints and priority tributary areas, doing activities such as large wood placement and improving floodplain connectivity. Some of these restoration elements that are underway or are going to be used to meet those goals. Seed collection and propagation. This began in 2018 It's collecting Yurok tribe and a number of tribal partners in the basin are doing this work underneath the umbrella of RES to collect native seed from the basin and then take native seed sources to nurseries to propagate and increase seed yield. To date, we've collected and propagated over 11 billion seeds, and we are on track to meet the 17 to 19 billion seed target that will be used to reseed the reservoir, former reservoir footprints twice over. That's a little over 2,000 acres of former reservoir footprint that will experience revegetation efforts. Along with the seed collection and propagation, there's invasive exotic vegetation treatment. This has been ongoing for the last 2 years. The intention of this is really to build a buffer around the former around the reservoirs. We will not be able to eliminate IEV. However, there is a very strong IEV seed source around the reservoirs, and we would like to build out a buffer to give the native plants and the revegetation effort a better opportunity to become established once the reservoirs are drawn down and that newly exposed reservoir sediments become available for revegetation. Reservoir area and tributary restoration. This goes back to those 3 goals. It's principally looking at volitional fish passage, sediment stabilization, things like connection to the floodplain, and then enhancing the tributary habitat areas through things like placement of large wood, which is identified here as number 4. That will be done via helicopter and ground-placed treatment. The restoration design at this point is at a 60% design level. This was done in coordination with state, federal, and tribal partners, and has been used throughout the permitting and FERC process to date. The intention is that once the reservoirs are drawn down and the reservoir sediments have had a period of evacuation and some settlement, that we will do aerial data capture then to map the actual design surface. So that will be LiDAR, photogrammatic, and orthorectified imagery that's going to be used to develop our actual design surface. And then we will progress the drawing set in coordination with state, federal, and tribal partners to the final design over the 2024 period, and then implement more ground-based restoration in our tributary locations in 2025. We have priority tributary areas that are identified for restoration work. In J.C. Boyle, this includes the lower portion of Spencer Creek, essentially within the area of reservoir influence. In Copco, number 1, it's Beaver Creek, which is a little bit over a mile of restoration that will occur on that tributary. And then in Iron Gate, it includes Jenny Creek and the Scotch Camp Creek complex, which is going to be our largest tributary restoration area at a little over 1.25 miles in length. As a kind of a footprint or a representation, you can think of conceptually how this is going to apply across the reservoirs. Once the reservoirs are drawn down and the dams are removed, the Klamath River will reoccupy its historic channel. This will restore the main stem channel alignment. We anticipate that it will reoccupy its historic alignment given the sediment and geomorphic conditions within those reaches. We will then have sediment stabilization with sediment removal and revegetation efforts throughout the former reservoir footprints. And then within our priority tributary areas shown here with Beaver Creek, we will have more on the ground restoration activities to ensure volitional fish passage, not only within those tributary features, but also through them to access historic anadromous habitat that is located above the hydroelectric reach. This is really focusing on ensuring volitional fish passage and connection to the floodplain through and sediment stabilization actions. At the former dam footprints, the channels will be reconstructed and they will be monitored to ensure that the design flows and volitional fish passage is meeting the objectives of those respective locations. And so the intention here is to move from the lentic to a lotic system and to have a restored former reservoir footprint within, to really accelerate that process over the next few years. Now, I mentioned monitoring performance. This is really what RES is being held to, and I'm going to identify some of those elements here. And once again, thinking about those different project timelines here, each of these slides will have a timeline on the bottom, and you can look at those different periods of the project depicted here. And this will just be a quick reference for where we are talking, what phase of the project this is occurring within. So revegetation, this is going to occur at all phases of our revegetation monitoring, will occur at all phases of the project, beginning with pre-drawdown activities. We've established permanent reference plots and have the IAV treatment that's ongoing. Once the reservoirs are drawn down and we begin our revegetation efforts, we will have we will establish treatment and control plots for monitoring. Control plots are intended to be small locations where no seed application or IAV management will occur, just so we can evaluate how the revegetation effort is faring compared to reference locations and control locations that are within and near the reservoir, former reservoir footprints. Anticipated data collection will include information on landform, species richness, tree and shrub density, vegetation cover, non-native vegetation relative frequency, and include photo documentation of those monitoring points. Much of this effort's being led by the Yreka tribe and Josh Chenoweth, who was involved with the Elwha Dam removal revegetation effort. Water quality monitoring, Randy mentioned this prior to my talk, and this is a very significant component of our monitoring requirement. It extends from the pre-drawdown into the drawdown and post-drawdown periods. It is really building off the existing water quality network that is in the basin. However, there are more robust monitoring requirements for the project that are required to begin 1 year before the drawdown. So for the purposes of our planning, we anticipate that to be January 1st of 2023. That's when the project's baseline water quality data is required to begin. We have installed and will have operating 9 continuous water quality stations. That's 3 new stations that will have gone in for this project. And we will be looking at a minimum of 5 water quality parameters or constituents with that continuous monitoring stations. We also have a series of water quality grab sample sites. There will be 9 of those, looking at, I believe it is 11 constituents of interest. And then we will have sediment grab samples that are done at 11 locations, looking at 17 constituents, mostly related to metals and toxicants. The duration and the frequency, the cadence of those different sampling events can vary based off the stage of the project, and they're all spelled out in the water quality management plans for the project. I will touch on those here in a little bit, but this is the framework for the water quality monitoring that will be done. And as you can see, the water quality monitoring requirement extends throughout the lower Klamath River system. So much greater area that's involved with our monitoring than just the hydroelectric reach. Volitional fish passage. This is really critical to meeting that primary goal of restoring a free-flowing Klamath River. And the intention of the project is to restore access for anadromous salmonids. The monitoring that will be done for this will extend from the drawdown period through post-drawdown. And it will be done through a number of different ways. It will include field collection by field surveys by ground crews. It will also include aerial data capture by means of collecting LiDAR, photogrammetry, and orthorectified imagery, so we can monitor areas of primary tributaries of concern, the main stem river, and ensure that volitional fish passage is occurring within our restored footprints. What we're looking for with volitional fish passage is evaluating whether or not residual reservoir sediments are causing blockages or impediments to fish passage. or if anthropogenic debris associated with the dam removal or prior dam installation activities, so think old culverts, things like that, are causing impediments to fish passage. That is what we'll be evaluating for. And as I mentioned, this is maintenance as well. We will then be correcting those if we are encountering them. So it's not just monitoring to identify, it's monitoring to correct. In the drawdown year, that is the year we have the greatest aerial extent of coverage that we need to provide. It is approximately 49 miles of main stem river and tributary habitat that we will monitor, beginning with Cottonwood Creek below Iron Gate, which is very close to I-5, extending up through the hydroelectric reach portion of California, and then from the state line of California, Oregon, up through the former J.C. Boyle reservoir footprints. The duration of time that we're monitoring these various reaches can vary based on the different stages of the project. However, for each of our monitoring events that occur, we will be monitoring the 22 miles of former reservoir footprint that will then be main stem river and fish-bearing tributaries. I've mentioned aerial monitoring and data collection a couple of times. It's a very important tool that we're going to be using to inform not only design, but our monitoring. It's going to be done through a couple different ways, and we'll begin during the drawdown period and extend through post-drawdown. We anticipate anywhere from 2 to 4 aerial captures done during the drawdown year to help inform restoration design. By that, what I mean is we anticipate fixed wing airplane flights being done to collect LiDAR and high resolution aerial imagery that we'll be using for design. And then we'll be complementing that with UAV or drone based LiDAR data collection, photogrammetry and orthorectified images to supplement and provide some more focused areas of monitoring. So for an example, we may be providing more frequent drone flights at certain key tributaries if we're monitoring sediment movement as it goes, as it progresses through a spring pulse flow, for example. In addition to the aerial data capture, we're going to have a network of ground-based photo monitoring points throughout the project area. This will begin in pre-drawdown activities and extend through the monitoring and maintenance periods. The purpose of this is will depend on the actual monitoring activity and performance criteria we're trying to meet. However, it will include everything from field crews going out to fixed tributary locations when they're doing their monitoring to reoccupy and take photo monitoring points at different points in the season to show whether or not sediment blockages are occurring, all the way to fixed timed or automated photo capture of more landscape based monitoring points to show ecological change and recovery within the former reservoir footprints. There's a significant amount of data that's going to be collected and used for the compliance elements, and we'll be hosting that on the Klamath River Renewal Project's data management platform. This is a data sharing platform that's under development and is intended to focus the restoration, compliance, data collection, and reporting elements. And this is going to be a platform that will have different access levels available to project stakeholders as well. And so that can include everything from access to the real-time water quality data that's uncorrected to say our monthly monitoring compliance reports with corrected and fixed data points for any corrections that were needed. We do anticipate that there will be a public access element to this platform. And so for the researchers that have engaged us on water quality data sharing, we anticipate that this is going to be the vehicle that you will use to access the water quality monitoring results that we have and the data that's coming in, and we'll have the ability to download those files through things like CSV files. I mentioned some of the fisheries and aquatic activities that's going to be done. I think these are some rather unique opportunities for data collection and capture and sharing that's going to occur. And these really fit into this category of compliance elements that are being done to minimize the impact of the project on listed resources. So prior to the reservoirs being drawn down, listed suckers within the project area will have a capture and relocation activity that's conducted and completed. Either we anticipate in spring of 23, could get punted to the fall of 23, depending on a couple timing elements. But this really builds off of a 2-year effort that was conducted under KRRC that looked at population estimates for the reservoirs. And that field effort was intended to trial different sample collection activities and help inform the salvage planning that would be done for this project. Data that's going to be collected during the salvage efforts include the identification of species, sex, length, weight, genetic samples will be taken by fin clip, and individual fish will be pit tagged, allowing for a genetic library to be developed for translocated suckers. Additional relocation activities that will occur prior to the reservoirs being drawn down include the relocation of overwintering juvenile Coho salmon from the main stem Klamath River. This is below Iron Gate. There's a target of several hundred overwintering Coho salmon that we intend to target to try to capture and relocate from 15 different locations below Iron Gate. The purpose of this activity really is to move this rather unique life stage of Coho salmon out of the main stem river the month before reservoir drawdown begins. And so that's really going to be that acute change in water quality that would happen and be detrimental to Coho. We'll be relocating those fish to tributaries and off-channel habitat where they will be able to volitionally relocate back to the main stem or continue rearing in those areas. During the drawdown, we will also be monitoring 13 key tributaries between Iron Gate and Syad Valley. We will be monitoring the tributary confluences for water temperature, dissolved oxygen, and fish behavior. And then in the main stem, we will be using the water quality management monitoring framework that has been built, the continuous water quality stations, to monitor suspended sediment concentrations and turbidity. That'll be done through regression analysis that is underway to give us the ability to look at real time what the water quality conditions are in the main stem. If target metrics are exceeded for both the main stem and the tributaries, we will consult with the Technical Aquatic Resource Group, which is made up of state, federal, and tribal fisheries and aquatic scientists, and determine if we're going to undergo capture and relocation of out-migrating juvenile salmonids. Principally, the purpose of this is to try to minimize the impact of the drawdown on that out-migrating Yreka class from those 13 tributary locations. And then to help minimize some of the impact that occurs from the drawdown on spawning salmonids within the main stem, this would be impact to fish in 2023. There's a target amount of spawning material that it needs to be counted for above Iron Gate. As we all know, the dam removal activity is slated to reconnect tens to hundreds of miles of historic spawning habitat, depending on the species. We need to ensure that a certain target amount of spawning material within both the tributaries and the main stem are available to the fish. And if they are not, we will have to account for that with the restoration design through doing spawning habitat enhancement elements and try to make up that difference. We will be using both field crew and aerial data capture to identify locations where spawning material occurs, GPS locate those, and then report those out. I can say it's been great that Trout Unlimited and National Marine Fisheries recently conducted a very thorough evaluation of spawning material above Iron Gate, so we feel confident that we will see that material. But if it is not encountered in the ways that we've determined they need to be accounted for, we will make up for that difference with the restoration design. So I've talked a little bit about these different either monitoring elements or kind of objectives that we have. This is really what the performance of the ecological restoration is being either evaluated against or evaluated with. There are very detailed management plans that have been filed with the Federal Energy Regulatory Commission, so they're publicly available, that spell out more of the means and methods for how this work will be done, the performance criteria that the project is going to be held to, our schedule, and our approach. Principally, I would direct you to the Reservoir Area Management Plan, the Terrestrial Wildlife Management Plans, the Water Quality Management Plans, and the Aquatic Resource Management Plans. Those are really the key ones that are dictating how Resource Environmental Solutions, or RES, will be held responsible for the ecological performance of this project. Those were filed with FERC in 2021. They were used for the NEPA process and have been accounted for throughout the government approvals. They were not put together in a vacuum. They had many years of state, federal, and tribal input and contribution and coordination to develop those. And we're in the process of trying to finalize those over the next 2 months to account for some additional additions that have occurred through things like the final EIS being issued and some of the staff modifications that require some additional work to be done. A couple considerations just for people who are intending to do research in and around the project area. The dam removal and restoration construction windows are very compact. We have a lot of work that needs to be done within a narrow time frame, and that access to the hydroelectric reach will be limited. This is principally due to safety concerns. There's going to be a lot of equipment moving around to achieve the goal of this project. And we will have we'll have some very changed conditions within the reservoir footprints themselves, particularly during the reservoir drawdown year and then the restoration construction year. Because of that, access is going to be limited and needs to be coordinated with KRRC's designated representatives for access into or through the project area. I bring this up because if you're planning research associated with the dam removal and you need to have access to those areas, you need to begin that coordination now so it can be done safely and in compliance with the project. I also would like to point out that principally, the project affiliated data collection is being done and focused on meeting compliance. We have objectives that we need to meet, and the data needs to be collected to that standard. And that's just important for everyone to consider. There will be data that is available to share, and then we anticipate potentially some limited resources available to support outside data collection activities. However, our objectives may not necessarily meet the objectives of everyone in the room as far as the type of data you would like to see. That is done principally because our objectives are to meet compliance for the completion of this project. With that, I'm at time. Wanted to provide a couple RES project contacts on the board here. This presentation will be available post this meeting. And there are also a couple websites that I would direct you to if you do not have those, including I would call out, this is the link for the FERC e-library for those 2021 filed management plans, where you can dig more into the ecological restoration and monitoring work that's going to be done for the Lower Klamath project. I realize that I've taken well up all of my time. Okay, great. So I'd be happy to field a couple questions. Also, my colleague Dave Kaufman, who's the restoration program manager for the Lower Klamath project, will be on the panel this afternoon and available to answer questions as well.
All right. Thank you, Dan. We've got some questions that have come in through the chat. Are there any questions in the room at all? And if you do have one, please just come up here to the microphone. I apologize for the meeting controls that keep popping up, especially to you, Dan.
No problem.
I'm going to see if I can make Josh the co-host without crashing the meeting.
Before you do that, why don't you take the questions from the chat?
Yeah. See if I can pull these up. All right. First one that's not related to Zoom. Dan, how frequently will the post drawdown surveys be conducted?
You already
Great
answered that question.
Great question, Desiree. Happy to follow up with you too, a little bit more specifically, but we do anticipate a minimum number of flights. However, those will likely be supplemented with some more focused areas. It's gonna be a really dynamic system. Once the reservoirs are drawn down, we anticipate that the spring flows could cause the reservoirs to refill and then have to draw down again just based off the capacity and the hydraulics of the diversions and the tunnels that are being used. And so, you know, we will continue to collect the data that we need to be able to inform the design. So that way we feel confident that we have things like our volumes and our target locations for features.
And then if you want to read.
Sure. Sorry, I can go through from Bill Tenniswood. Are you considering velocity barriers in the bypass reach? Great question, Bill. There are target velocities that, well, there was hydrodynamic modeling that was done at the dam and anticipated channel footprints that were used to model anticipated flow conditions. We will have some flow evaluation work that's done principally within Oregon as part of the Oregon Department of Fish and Wildlife's fish passage permit. And the objective is trying to meet that the conditions are representative of other reaches and are not prohibitive for fish passage.
We have a few more questions in the chat. Maybe I can ask if Dan can answer those in the chat.
Sure.
That way we can deal with some technical things to address here. I want to thank Dan for a great intro talk.